Okay, let's do this one again. So, starting from the top, let's say I have my curve here. Whoops, let me do that again. That does not look good. Whatever, good enough. I'm looking for the value that cuts off the top 10% from the bottom 90%. Okay, looking for that X value. So, much easier concept. What you're going to do is you're going to go in your calculator. You're going to go to the distributions menu. Okay. Second, vars to go to the distributions menu. And if you have the X value, like kind of the problems you did before in this section, if you have the X value, you're looking for the probability, you're going to use normal CDF. I'll show you an example of that in a second. But since I have the probability or the percentage and I want to find the X value, I'm going to use inverse norm. So you're always going to use either option 2 or 3. So I'm going to go to inverse norm. First question at once is the area. Okay. Now, just like the Z table, that means area to the left of my value. So even though this is top 10%, we don't care about that. I want to know what cuts off the bottom 90%. So I'm going to plug in 90% here, 0.90. And then you save yourself a lot of time. You can just plug in the mu from your problem, 33, and the sigma from your problem, 5.2, and it'll spit right out the value that cuts off the top 10%. 39.7. We might have had 39.6 because we actually weren't as accurate because we used a Z table to 100. Whoops. And you can do it all that way, okay? So you know this goes to 39.6. And I want to know the above the bottom 69%, so I can go back in and just plug in 69%, 0.69, and do it that way. This is going to be 35.6. Okay, much easier when you have the TI-84. So let me just grab one of your other problems. One you've already done probably. Let's see here. So I'll do this one just to show you. I know you have the answer correct, but I'll show you where to do it. And one where it just says longer than something. Okay. Okay. Yeah, we don't care. We don't care. All right. So this says particular fruit's weight is normally distributed, mean of 310, standard deviation of 15. You pick one fruit at random. What's the probability it'll weigh between 318 and 350? Draw your curve. Doesn't matter how good it looks. So this is 310. So I'm looking for the probability it's between 318, somewhere right here, and 350. 350 is somewhere up here. Looking for this area. Okay, so when you have the X values and you want to find the area, you're going to use the other command. Second, distributions, normal CDF. So I'll hit that. It's going to ask for your lower bound. Well, what's the lower bound? What's the leftmost point I'm looking at? That's going to be 318. I'll plug in 318. My upper bound, that's going to be 350. My mu is 310. And my sigma is 15. And you'll see that when you do that, you get the same thing you got, 0.2931, rounded to 4 decimal places. Okay? Much easier. But I don't require everyone to buy the same calculator, so it's beneficial if you have it. If not, you have to use a Z table. Now this says, find the probability that it lasts longer than 7 years. So I'll draw the chart real quick, the curve. Let's just do this, whatever. Good enough. That's fine. Mean is 9.8. 7 somewhere right here. I'm looking for the probability that it lasts longer than 7 years. I'm looking for that area. So you're going to go back into distributions menu, normal CDF, because I'm looking for a probability. My lower bound now is 7. But what's my upper bound? You might have saw in the videos that this curve goes forever in this direction. Okay, they don't ever touch. They're like asymptotic. They get closer and closer, but don't ever touch. So when it says upper bound and there is no real upper bound, just put a really large number in there. I don't know, 100,000 should be plenty fine. My mu is 9.8. And my sigma is 2.2. And you'll see we get the same thing. You got 0.8984. Okay. If it said lasts less than 7 years, well, that means I'm looking for this area. Whoops. See, why doesn't it change colors for me? Purple, purple, purple. There we go. I'm looking for this area. So in my calculator, I'm going to go back to normal CDF. Second distribution. Now my lower bound, there is no lower bound. So I'm just going to put a really, really negative, a large negative number, negative 100,000. My upper bound now is 7. Everything else is the same. Should make sense that this is the complement, so this would be 0.1016. Okay. And that's how you do these types of problems in the calculator.